Hello folks, I've been trying to get around to making this video for a month or two and just couldn't seem to find the time to do it, so just had to stop and take a stab at it. I thought I'd make a video here. Someone on the forum suggested, I think it was Jared, that this might be good to share. He said to his knowledge he didn't think anybody else was making ribs this way, but when I started, I thought everybody was making them this way. I didn't know, so this is the way I started doing it. And didn't realize that till just recently, that no one else is making them this way, hardly. I saw the fellow on the internet, Mr. Snap. He had a good YouTube video on making sheet metal ribs this way for his bearhawk, and I saw he was in his woodworking shop, and I sort of enjoyed working on wood a little bit too, so I thought, well, I watched him, and the stuff he was doing seemed to make sense. So I thought, well, I'll try that, and I did. And so I'll show you what I did. It's pretty similar to what he did, but I noticed when he did his video was fairly brief, and he didn't talk too much about the hydraulic pressing part of it, the hydroforming. So he just kind of went through that kind of fast. Kind of a blur, as you say. So I'll show you what I'm doing here, in case you'd like to do it too. This is what we get when we get a finished product here. I've already alodined this. I have a whole mess of them hanging on the wall over there. I'm almost done with these, so I wanted to make a video of how I did it before I ran out of raw materials. So this is what it looks like, and I have to say, as I've gone through these, that I've gotten a little bit better gradually as I've went and learned a few things. So I'll try to pass on those things momentarily here. So, okay, what I did was I got my sheet metal locally, and it happened that this particular supplier, he doesn't have his sheet metal plastic filmed anymore, because he said too many people complained that they had trouble getting the film off. So he only gets it naked now. So I took my sheets and laid them out on my table and got some carpet protective film. I think it's 3 feet wide or however wide it is, sticky backed. And I just rolled film onto my aluminum before I started, and it really helps me. I don't get nearly the scratches on it I would otherwise, which I don't want any. We scratched it a little bit, shearing it over at his place, which I would have rather not have, but I filmed it when I got home with it. So the first step is I took my, we're having in the middle of a hurricane, I think it's stirring up pollen here. I took my form, which looks like this, it's just the shape of the rib, basically, and I laid that down on my raw material and laid it around and sharpied around it, so I had a outline of all of them, and that allowed me to get them as dense as possible on the sheet. So I take best advantage of my material, drew around them with a little bit extra, and then I have a little pneumatic, what they call a body saw. It's a little tiny saw about this long that's pneumatic and has a blade that oscillates. And I found that that's good for roughing out my material because it doesn't curl it like a tin snip would. So I can just go around it like a carving knife going through turkey and rough these out. And then after I rough them out, I put them on the bandsaw and cut it within probably a 1/4 inch of the line I drew. Get them fairly close, maybe less, 1/8 inch maybe. And I end up with a blank that sort of looks like this right here. And that just gives me that outline, basically. And then the next thing I do is I have these two pieces here. This is a form right here that makes my blanks. And there's two pieces that look like this out of MDF. And these are made off the master form. And what I did is I put a pocket on the back for bolts, 3/16 aircraft bolts. And what I do is I take my blank and I lay it down in between these and center it up so I make sure that I have some margin sticking out all the way around on this. Doesn't have to be much, just has to be some all around. So there's not going to be undercut. So once I get that in there, push this around till I got margin. Then I take one of my Sharpies here, I draw around the circle inside it, and then I also have a punch here that I made, 3/16 punch that goes down through these bushed holes, and I'll punch these holes, make a dimple, and then go to the drill press and drill 2 indexing holes. And those 2 little holes, of course, those serve to line this up with everything as you go along. So I punch those, and then I've drawn my Sharpie circles, and then once I've got my circles drawn here, then I have a punch over there. It's a foot-operated hole puncher for sheet metal. I have about a 1-inch round die in it. So I just start at the edge right here, like you see here, just inboard of the line I drew, and I just start punching around the perimeter here until I get the whole perimeter punched out. And that leaves me a little bit of a rough edge here, and I punch it so there's a little hanging over towards the middle. So that roughs out my hole. So then the next thing I do, usually do all of those, for however many, a batch of 4 or 5, or however many I want to do. I put these bolts through here like this, and then I take my blank here, and I thread the blank down over those 2 bolts right there, and then I put the other piece of wood up on here. This is the mate to the other one that's on the bottom, with the holes lined up here, and then I put a nut on it, and that makes me an MDF sandwich, you can see here, with this stuff in between, okay? And it's lined up because the bolt's passing through the wood and the sheet metal. So then the next thing I do after that, let me turn the camera here for you. Turn it around this way. I have a router table here I built just for this purpose, and it's got a router bit, a 1/4-inch diameter bit here, with a bearing on the top. So what I do is, once this sandwich is tightened down, it's a unit now, so I put that down through the hole, turn the router on, and then I just push this thing around the holes, and then I take it on the outside and run it down the perimeter, letting the bearing guide on the edge of the MDF. So I have, this is the guide, and this is the bearing that it's running on. Okay, so that basically duplicates in the sheet metal what the MDF looks like right here. Okay? And I can do 1 in the sandwich, or I can do, I've done as many as 5 at one time. And it's just, if you do more, you have to go slower with the router, because it loads down a little bit. And you want a nice finish, so you don't want to go real fast. So then you take your nuts off. Say I've done 4 or 5 of these, for instance. You pull your blank out, and you end up with something that looks just like this. It's perfectly cut on the perimeter and in the holes and on the back. You just go all the way around it and do the holes. And then after I do that, I have a deburring tool that I go around the holes with and around the perimeter. And then I'll take a little bit of, I think it's 220 aluminum oxide sandpaper, and go down this and get rid of any chatter marks that the router left, and do do like a 45 around the edges. And I'll do that and just feel it with my fingers and make sure there's no texture there. You don't want any little nicks or anything like that. And it's safe to use aluminum oxide on aluminum. You don't want to use anything else. If you use carbide or any other flavors of sandpaper, the little particles break off and go into the aluminum and cause you a spot for corrosion or crack start or any number of bad things. So aluminum oxide is the safe one to use. And you don't want it too coarse either. You want a nice fine finish. Okay, so that makes us our basic blank. So then, once we have our blank like this, then we're ready to hydroform it. We've deburred it, made it slick on the edges, and got it ready to press. And I don't know if you can see it, but you can see the edges of my plastic film kind of hanging out here. And I like that. It's got some bubbles in it, but that doesn't hurt anything. And that just protects the surface from anything bad that could happen. Okay, for the purposes of this video, what I've done is I've taken a blank just like that, and I've put in over here in the hydraulic press, and we'll go over there and look at that. I did that just before the camera started. Okay, and this is my press, and you can see it's got a 30-ton hydraulic jack that's pushing up here. What I've got here is two big thick sheets of rubber, one on top of the other, and then in here, you'll see in a minute when I slack it, we can go ahead and do that now actually. So I'm going to just take my handle and turn this, and it's going to come down. You can see it. And down we go. Okay. Now, I have this piece on top. I'm just using that as like a washer almost to spread the pressure out. But it has another function we'll talk about in a second. So we pull our form and our sheet metal out. Now the way I'm doing this, I have it upside down on the rubber. So when we flip it over, you'll see the sheet metal, and I have two number 3 or 3/16 rivets, maybe number 5 I guess, or whatever that is, that are holding this into the form. Okay? And here's my hydroform part. We'll look more about that in a second. Here's my form that I'm pushing against. I took 2 pieces of 3/4 MDF and I cut this shape out from the master rib and glued these 2 pieces together to make myself an 1.5-inch piece, 1.5 inch thick. Of course, drilled my holes from the master form so that these are at the right geography. And then I took my hand router and put a 45-degree chamfer bit in it and cut the edge of this down gradually until I got to the right width so that the flange is the correct width. And I believe I cut these center holes out with a big fly cutter in the milling machine so that I got them nice and round and got them right where I wanted them. And the reason I made this out of 2 pieces of MDF is so it's double-sided. I can do the left ribs and the right ribs using the same piece of material as a form. Now, one thing I did that seemed to work nicely is once I got this cut out and got it shaped, I took something called Minwax wood hardener, which is something, I guess it's used for restoring antique pieces of wood where you want to paint this stuff on. It looks like water basically, but it soaks into the wood, and after it soaks in, after some number of hours, it turns almost to like hardened acrylic. So I took a bunch of that, a quart of it, and I painted this thing with it, a bunch of coats, and it soaked way in deep and then hardened. So this piece of MDF now is more like almost like plexiglass now than it is MDF. So it has some rigidity on the surface, and I was hoping that might reinforce it from being hit against on the edges where it wouldn't chip or deform too much. And it seems to be doing that. So that stuff seems to work pretty nice, and it gives you a nice hard finish that you can sand and make it slick too. Okay, back to what we were talking about. So I take this thing, let me set wood here just for a second. And I take my blank that we just showed you, I lay that on top of there, and then I take my 2 rivets that are really just guide pins. And the reason I'm using rivets is they have a round head and they won't make a dig mark in my rubber because they're on the heads are on the rubber side. Okay, so those just push in and they keep that located so it can't slide with respect to the form. And then I spray, like Mr. Snap did, I spray some lemon pledge on top of this thing around it before I put it in the press, and then I flip it upside down, slide it into the press, like so, and I take this big old backup thing, and I just slide that up in there, and that's just to kind of be a kind of a spacer to help protect my form, and then I just pump the darn thing up, and then after I've done pumping it up, it looks just like you saw before I slacked the press, and then once the press is slacked, we get this. Now this is all cooked up with lemon pledge here to some degree. See if I can wipe some of it off. Okay. So what this does is this actually, as you're pumping up, this form and the part, your work, gets sunk down into the rubber just from the pressure from the jack. And the farther it goes down into the rubber, the higher the PSI the rubber is exerting on the sheet metal. But not only is it just exerting pressure, as you're pumping it up, the rubber is conforming to the shape of the form, and it's actually folding the sheet metal around the corners, kind of. And of course, the farther you go with it, the more it envelops the sheet metal, and the farther it bends it around those corners. If you just press it a little, you just get a slight bend. So I started out with just one sheet of rubber here, and I discovered I could get it about a third of the way. So then I started experimenting with two thicknesses of rubber, which I believe this is 4 inches now, I think. Let's see. Can't remember if it's 3.5 or 4. Okay, yep, that's 4 inches. 4 inches of rubber there. And what I discovered was when you're pushing this form down into this rubber, once you get most of the thickness of whatever piece of rubber you're pushing on, you sort of run out of rubber to push out of the way, and then the force really increases and you can't go much further. So when I added a second piece of rubber there, that allowed me to go with more displacement down in the rubber stack because there's more rubber there. And that in turn allowed these edges to fold farther around the corner. And I discovered the second sheet also helped my flanges to bend the rest of the way. With just one sheet I was getting about 20 degrees of bend, and then with the second sheet I'm getting right at 30 degrees, or so darn close it doesn't matter. And then my flanges up here, this one didn't bend as much as I could have bent it, but I'm getting about maybe 70 to 80 degrees if I push it all the way. And that's kind of nice because you're not getting any significant problems here at this bend line. And I think one of the nice things about this method is just like when you're bending metal in a sheet metal brake, you're doing the whole bend at one time, so it's not like you're bending down here and then working your way down it, and while you're doing that it can warp out of shape, which it will. So this is helpful because you're bending the whole perimeter all at one time. And so that maybe helps to make this bend more uniform and the overall shape of the part doesn't distort quite as much. And the big fancy hydroform machines, they're way higher pressure. You know, they're like 100 tons, basically. And they make the part look like it was electroplated onto the form. It's ridiculous, but this is just my simple homebrew here. So this gets our bend most of the way. So then the next phase, after we do that, let me get this out of the way. Okay, my next step, once I've bent it in the press, is I take this and put this back on the form that I bent it on, okay? Which is how it got bent in the first place. And I take this spacer, which is 2 pieces of hardwood 3/4 inch plywood that's also drilled off the master form, and I lay this on top of there, and I have some bolts that go through those 2 holes, really long bolts. And that makes me a sandwich now. And this slug here is cut just a little smaller than the form. So that exposes my bend line, basically, so I can get at it. Okay, now let me show you what's next. I'm going to turn the camera around here a little bit. Alright, now you're looking at the router table that we showed a minute ago. So I've just recently added a couple of these Woodworking Vices. I have another one in the other room I've been using, but I added this one here just so I wouldn't have to walk so far. So we're going to open this sucker up. And of course I'm going to oversimplify this just a little bit for illustration purposes. We're going to tighten the vise down on this thing. And in the other room, let me get it lined in. Of course I don't have the bolts to it right now to line it up. In the other room I have a couple of big bar clamps that I put here that help squeeze this upper perimeter together a little closer to the bend line. I clamp those down on it too, just for extra pressure. And then I take my little tiny dead blow hammer here, and I run down this with the dead blow hammer and finish that bend off and get it as far as I can get it here, which is about 80, probably like 85 degrees or something like that. And I do that on both sides. And I didn't quite press this one 100% on the press, but usually if I push the press together as far as I can get it, usually there's not much more for this hammer to do. I'm only getting a little bit more with the hammer. But that's what I did, okay? That gives me a little bit more of the bend. So then, once I've done that, then this piece comes out of this thing, pull the bolts out, take this apart, and then we go back over here, and I'm going to move my camera again for you to a new location here. Alright, that looks pretty good. Now we go back over here, and of course, since I've just bent this with the hammer, the bend is not to 90 degrees yet. So my understanding is Bob kind of robbed his design methodology from the RV series of builders that are building RVs as far as how he designed the wing. And I guess he liked their little machine that they bend their bends with, because I think somebody suggested this was the thing to do your bends with. So here's a rib right here that I've already put it in that block, put it in the vise, and I've already turned this over with the rubber dead blow hammer. And then before it came out of the jig, I marked the edge to where my flutes are going to go. And of course you want to make sure you mark that so you don't end up with a rivet hole being in the middle of a flute. You want that in the flat, so that helps me avoid that, of course. So I've already turned this with the hammer on both sides, and as you can see, if you look down it, it's got a little bit of what you might call a potato chip shape going, and that's just kind of inevitable at this phase. You can see it from both sides. Okay. Now here's a finer point. When I first started doing this, when I got it at this point, what I would do was I would take my fluting pliers, because this potato chip looks so scary. I would take my fluting pliers and just flute each black mark here on both sides. It's pretty easy. And that pretty much un-potato chipped it for the most part. And then after I'd fluted it, I would bring it over and put it in this little straightener right here. But what I noticed was, of course, once it's fluted, you can only straighten between the flutes. You can't straighten 100% of this bend line, because you can't. If you put that thing where the flutes are, you push your flute out, right? And I noticed that when I was done fluting and done with this procedure, with this overbender, when I would put it down on the table, I'd put it down like this, and then I'd play with the fluting pliers on the table until this thing didn't rock anymore, until I got it perfectly flat on the table. But then I noticed if I flipped it over and looked at the middle surfaces down against the table, I had a little bit of a belly in the middle, just slightly. And I didn't like that. I want it to be as flat as I can get it. So about halfway through making these ribs, I just for fun, I thought of a variation. So what I did was, instead of, at this point, fluting it, I thought to myself, well, what if I put it through the straightener and then I flute it? So I tried that. And what I found is by putting this overbender down the bend line, where you can overbend 100% of the bend line first and then flute it, then when you're done, you don't have any raising up of the middle of the rib when you lay it down flat like this. It all goes away. So apparently that last little bit of belly I was having was because I couldn't overbend where the flutes were. So just by reversing those two steps, that gave me a rib, as you can see, like this one, for instance. That's one of the finished ribs, that when you lay it on the table, you don't have any rocking. It's the edge of the flange is perfectly level. I've done that with the fluting pliers. And then when you flip it over, when you push down like that, you really don't have any belly of any significance where the center parts are standing up in. And just changing the order between the fluting and the overbending solved that problem. So basically, since I've already rolled this over with a rubber hammer, all we do is just stick this in here. And the plans for these don't normally have a handle quite that long, but I just happen to have a 3-foot piece of this that I bought for this. So I left it a little long, and that worked out nice because that extra weight there gives this a little momentum. And you can use that to kind of like give you a little bit of extra, you just don't have to exert yourself so much when you're doing this. So I go down this and do about half the length of the little finger there so that I'm overlapped. Do it till I hear it do it bump where it's bottoming out. Just like that. Take little bites so they overlap. And I had to readjust the face angles once because I didn't quite have enough. It was bending until like 88 degrees or 89 degrees, so I took this part apart and played with it on the sander and increased the steepness right there a little bit until I got it bent in 90. And we just do both sides. Go down it. Just like that. Pretty easy tool, and it's efficient, it does a nice job, it's all wood, so it doesn't leave any marks on your metal. It's just soft enough to be friendly. This upper handle here is oak, and that's oak, and then that's just 2x4. So I've just gone down that one time each way, and then what we do is then we would take these pliers and we'd flute these, and you need from what I found, it takes just a little flute on the back, but the first couple, especially on the upper side here, it takes everything the fluter's got, at least on the first 2 or 2.5, or first 3, let me say. Everything you can put on it there, and then it reduces gradually until you get to the back. And then the bottom side doesn't take quite as much because it doesn't have as much curve. But I've noticed some people do double flutes up here in this upper section at the front because of this steep curve, but I found that just one flute will just barely do it if you squeeze it for all it's worth. And I'm just using the cheapest aircraft spruce fluting pliers. But what I did do is I took the Dremel and a little fob and some rouge and polished the faces that touch the metal, and then after I polished them I put some electrical tape up in there to give me a little further pad so I don't make any kind of a mark. So once we've done that, basically, then it's just a matter of laying it on the table and playing with the fluting pliers until you get it just like one of these, basically. And it's just about as simple as that. And once you're at that point, the next step is I take it in there in the sink and lay it down in the sink with some soapy Dawn water. Scrub it with a white Scotch-Brite or a green Scotch-Brite, depending on what the surface looks like. And then rinse it, put on my surgical gloves, rinse it off so my fingerprints don't touch it. And then I dip it in the iodine acid to clean it, the cleaner half of it. And then give it another rinse in the sink. And then down into the iodine it goes, and it comes out just like this. Pretty as a picture. So that's kind of what I'm doing. And it's so easy, basically, that I can't understand why you'd want to do it any other way. I've seen people doing it completely by hand, and that just seems like a lot of effort, basically. And even though I don't have a lot of these, my personality is such that even just 30 of them, I'd like them to all be really nice and all be the same. But, you know, that's just something that's in me that forces me to do that psychologically. Don't have to do that, of course. Probably most people don't. But another tool I discovered, I saw these on the internet and didn't know where to get one, and happened to be in Michael's Crafts, and I happened to walk into the aisle where they had the what do they call it? Beading supplies, where you make necklaces and bracelets and things like that. And they have rolls of wire and beads, and they have a little tool section. And in the tool section, I found this. And this is a little cast stainless pair of pliers that has nylon jaws. And if you notice, the jaws are curved, and they go into one another. And what I found was that there's times that this flange will have, especially up in this upper section, the first half of it, you'll have these little wrinkles. And even after you've fluted it, there'll be a little, on the flats, there'll be a little hint of what would you say, not a wrinkle, but a discontinuity, a little place where the plateau is not flat all the way across. And some places there'll be a little upward inflection. And I discovered I can take these pliers here and just lay on that inflection and just push down a little bit with the concave side up. And that just preferentially, just give it a little pressure, and you can see that pushing out that little inflection. And then that's just like a quality control tool, basically. And then when I get done with doing that, my last step before I go clean it and anodyne it, like a quality control step, is what I do is I take got a little machinist square here, and I lay that on the edge of the face of the rib, and then I sight down here, and I slide that all the way down the rib, and as I'm sliding, I'm looking to see if there's any ripples in that rib that would cause the sheet metal skin to stand up locally right there. So if I see any of those little ripples, I'll either take a pair of pliers and bend that ripple down a little bit, or I'll take those pliers with the plastic jaws and tweak it a little bit until this upper surface here is basically perfectly 90 degrees all the way down, and then there's no high spots. I've noticed that I often get a high spot right at the leading edge of these places where the flange starts. So sometimes I take a pair of pliers and just tweak that downward a little bit, and that clears that up. And that gives me a good little idea that it's going to be smooth when I'm done. And you can look down I don't know if you have way you can see it, but you can look down the surface here kind of and see that it's reasonably smooth. It's probably as smooth as I could probably ever get it, I would say, which makes me happy, of course. Let me think what else. Oh, mistakes not to make if you use this method. One little small mistake I made, but it was easily corrected, and I'll show you what it looks like. Other people have noticed this problem. This one doesn't have it in particular, but some have it worse than others, that you find that after the thing comes out of the form, this bend line has to be a particular minimum radius in order to not crack. And I was noticing that I was always finishing this bend off with a rubber hammer. The leading edge right here on the front, well, you can see it a little bit here, on both of these, that bend radius shrinks a little bit right at the beginning. And what I figured out later why that was happening was that when you have this flange in the form like this, and you have this plate on top of it, and you're hitting this down with the rubber hammer along that edge, it turns out that the first one of these backup plates I built, I cut the edge back away from the bend line a little bit, but what I did accidentally was I cut it back a little too far up at this front edge on both sides, and what that did is that allowed a little area up here at the front to not be in compression when you're bending this bend line with the rubber hammer. And the effect of that is that allows this area here to kind of squirm out of shape due to the stresses of when you're bending back here. When you're coming down this way and you get to about here, the stress from that bend line will bend this corner back a little bit. And what it's actually doing is putting a little pleat in this edge just inboard of the bend line. And that also, you get an accompanying little change in the radius there. So the way I fixed that is I cut a second one of these plates to fix that, and I specifically cut this second plate a little more, I cut a little less of it off around that corner right there, so that when this is sandwiched and I'm doing that hammer bend, I don't have as much hanging out. I have maybe right at the tangent of the bend line instead of like an 1/8 inch more. And that's helped to not put that little pleat in it. Still gets a little bit, but it's not nearly as bad. And somebody had asked on the forum, or I'd asked about it, and someone else had asked about it in the past, and said that they'd asked Bob about that little pleat, and his answer apparently was as long as you don't have a crack there, that it should be all right. So I've checked several of mine that had the worst ones that I had it. I did a dye penetrant test on them. Didn't show any cracks. So after that, I changed this plate to the one that supported it better, and that